Okay, in this video I want to talk about events and delegates in C#. Now this is a subject that can get kind of confusing, trying to understand exactly what's going on. The syntax and the methodology can get real confusing. So what I'd like to do is step back and try and give some analogies of real world stuff and hopefully help you understand what all this event stuff is and what we're trying to model and how it all works, so that when you're working with these in C#, it makes a lot more sense and you can understand what's going on. You see a lot of videos and training out there where people just go through the steps that don't really explain why you're doing it and what it all means. So I hope to help you in that aspect and show you some real world stuff. So what we'll do is we'll start out with an example. Let's say we've got an office here. We've got a bunch of people sitting in an office, and we have a supervisor and we have an employee. And let's say that the supervisor asks the employee to make 4 copies of a particular document. So he says, make me 4 copies of this document. And he also has a procedure for the employee to follow when he's done making the copies. And that is, when you're done making the copies, drop them on Carol's desk. And this might be Carol up here in the corner, sitting there. Drop them on Carol's desk and leave her a note telling her what they are and who they're for. So the employee has to follow this procedure once he's done making the copies. So let's say that the employee thinks he's got a better way to do this. And let's say his response is, no, I'm not going to do it that way. Anyone who wants me to make copies for them has to follow my rules. And here are my rules. You have to bring me the document first. I will work on that. I will make your 4 copies, but when I am done, I will announce to the entire office over the PA, the public address system, that I've completed the task. Okay? I'm not going to drop them at Carol's desk. I'm not going to leave a note. I'm just going to announce over the PA that I've completed the task. I will also announce who I am and where to pick up the copies. So I'll say, this is Joe. I've completed the 4 copies. You can pick them up at the table near the water cooler, okay? But that's all I'm going to do. That's my procedure. If you don't like it, then that's your problem. If you want me to work for you, you must follow my rules, no exceptions. So that's the process he's proposing to do. So the supervisor will ask for 4 copies. Joe will do it. He'll announce to the entire office the task is finished. And you got a bunch of people here, they're going to hear it. You know, some people aren't going to be listening. They're going to have their headphones in, listening to music. Some people are going to be talking to other people and not care about the copies. But maybe out of those 4 copies, 3 of them need to ultimately go to 3 of the employees. Maybe the supervisor is going to get 1, but he's going to distribute them to 3 other employees. And maybe 1 employee is going to file a copy. The other employee is going to put one in an envelope and mail it to somebody, and so on. But basically, from the employee's perspective, all he will do is get on the microphone, announce to the entire office the task is finished, and it's up to these people to receive that message and do what they need to do. That's not his problem. He's just going to announce that event that the task is finished. And he may tell them, this is Joe, and if you want to pick up the copies, go to a certain desk. So why is this proposed procedure good? Or is it good? Maybe it's not good. Well, consider this. Let's say there are 4 people waiting for copies, for those 4 copies. If every one of them has their own procedures on how the copy guy should deal with them, it can be very confusing. For example, you know, if one person is going to file a copy, the other person is going to put it in the mail to someone, the other person is going to do something else, and then the supervisor is going to do something else. The employee has to keep track of all those procedures, and he's got to go through, and it's very inefficient. He's got to go through and do all those procedures and keep track. And for example, what if Carol leaves? You know, the supervisor said put it on Carol's desk. What if she leaves? She's not there. She gets a different job. Maybe the employee will put all 4 copies on her desk, but Carol's not there, so they'll just sit there for a week, and the copies will get lost, and nobody will know what happened to them. And, you know, with these other people, what if their procedures suddenly change? You know, he doesn't want it filed. He wants it left for somebody else to do something else. When those procedures change, you have to go to the employee, retrain him to the new procedure, and it can get very confusing and complicated. So the idea that the employee has is that it's better to uncouple, what's called uncoupling those functions, and have a standard set of procedures. So in other words, the interaction between the employee and the clients, the people who are the clients of his work, should be very minimal. There should be very little interaction between the two. Each function should be kind of uncoupled and separate and have very little reliance on the other functions, okay? It should be a standalone function that only passes very little information that isn't going to change. So he does his thing, everybody knows that they need to be listening, and then they will take that information and do what they want with it. So it's a lot more efficient to have a standalone procedure that you can copy and you can use in other places, not a custom procedure that it's custom for each client that he's got to do something different. It's better to have, in many cases, a kind of a standard process that everybody follows. On the other hand, it requires that each of these clients follows that standard process. So, it's like anything, it's not perfect, but it's an efficient way to do things. So another example of this, you go into the supermarket and somebody spills something in one of the aisles, you hear over the PA, clean up in aisle 3. That is another example of a broadcast event notification where some guy in the back room gets on the microphone and says, hey, an event happened in aisle 3, and he notifies everybody in the supermarket, the employees, the customers, the supervisors, everybody hears that notification, at least anybody who's listening. So it's a broadcast event notification. Anybody can listen to it. Anybody can respond. It's up to the individual whether they're going to ignore it or they're going to respond. But basically the notifier, the guy in the back room, doesn't care. He doesn't care who's out there. He doesn't care who responds or if anybody responds. His job is to just make the notification. So if you want to do something like that, have basically an event-driven system that is uncoupled between the notifier and the clients who are receiving the information. How would you do that in C# code? Well, I've got a diagram here, basic block diagram, that shows a basic concept on how you might do that. And you've got the guy who's making the copies, I'll call him the worker class or method in C# terminology, basically a method or a class that does something. And when he is done with that, he will make a broadcast notification, an event notification that the task is complete. And over here, I've got a bunch of listeners, basically everybody in the office or everybody in the supermarket who is listening. And they are listening to that event. And when that event happens, when they're notified of that event, they will do something based on that event. You could also view them as subscribers to that event. They are, in their minds, the people who want some of those copies are going to be listening. They're going to be subscribing to that event. They're going to be paying attention. They're not going to be listening to music. They're going to subscribe to that event and be listening for that event over the PA system. Once that event comes, and basically it's a very simple, just a, hey, something happened event. There's not much information in there, just that an event occurred. They will do something in their heads based on that. So one person will say, oh, okay, I'll go grab the copy and I'll file it. The other person says, oh, okay, I'll go grab a copy and I'll mail it to somebody. And then the supervisor says, oh, okay, I'll grab a copy and I'll keep it on my desk, and so on. So you basically got the issuer of the event and the listeners or subscribers to the event that do something based on the event. Now, when you're going to code this, what you will generally do is you will model that broadcast as having a notification list. In other words, a list of subscribers who will be notified when that event is issued by this worker guy. So basically, the process will be something like, he says, okay, I'm done. He issues an event, and there is a list of subscribers, and you go down that list, and once that you receive that event, and you call that subscriber and say, hey, that event has been issued and that task is complete. So you've got a list of subscribers, you call one, you call the next one, call the next one, call the next one, and say that event has been issued, the task is complete, and then you can do whatever you want. Now in C# code, to get a little deeper into how you do that in C# code, you would have in each subscriber code, like if this was a class that did something, you would have an event handler method or function. And basically that is just a function or a method in C# that takes an event as an input parameter, and there is code in here in C# that does whatever you need to do. It doesn't matter to the world what you do with that. You have your own code, but the event function has to take this event into it in order to work. And each subscriber has their own version of that event handler method or function, but all of them are identical in that they take an event as an input and then they do something, whatever they need to do inside that code. And the list of event handlers that are called when that event happens is basically a list that says, when that event happens, call this function, call this method, and then call this method with that event, okay? So that's kind of, you're starting to see how you would do that in C#. And we also said that when you're talking about methods or functions in C#, they generally have a return value. They can return a value or they can return void. In this case, we said it's basically a broadcast going in one direction. You send out the notification. This guy doesn't care to get any information back, so it is a void return. So each of these needs to take an event in and return nothing because this guy doesn't want anything. So these all need to be standard events functions that take event and return void. Okay? Now, you can he can send out more than just an indication that his task is complete, more than just a simple event. He can also, we said that he can say on the loudspeaker, this is Joe, the 4 copies are done, and if you want to get those copies, go to the desk or the table near the water cooler, okay? So he can issue not just a event notification, but he can say, okay, who issued the event, which was this guy, and where the copies are located. All right, so you can feed this function more information other than just the event occurred. You can say who issued it and where to get that copy. And then each event handler can handle that information as they need to. So let's step back a bit and look at the events in the real world, okay? Those events can be just about anything. In our case, in this particular example, we said the event is the copies have been done, the task is completed. That fires off the event handler to call these methods and do what they need to do based on that. But when you're writing code, you can be simulating anything. You could be simulating a fire alarm, which is a broadcast notification in a building that you get the lights go off and the buzzer goes off and says there's a fire. That's an event, and that is, everybody's listening. Hopefully, everybody's a listener. They hear the event, and then they decide internally what they're going to do. They know what door to go out, where to gather with all the people. A traffic light is the same thing. A traffic light is a broadcast notification. The light turns red. That is an event that each of the drivers in the area notices. Hopefully they're subscribing to that event, and then they say, well, okay, the event is it turned red, I will then stop the car. If it's green, then I will go. If it's yellow, I will slow down. Same thing, clean up in aisle 3. That's a broadcast event notification. all the customers will ignore it, but one guy will be subscribing and he'll go clean it up. And on your computer, a very common one is a mouse button click. You click the mouse, it initiates an event and tells your methods that the button was clicked and you need to do something. So it's a very, very useful type of procedure to treat things as events and then handle them based on what the event is. So this list of event handler methods or functions that need to be called when the event happens, how would you do that in C#? Because really you got to keep a list, and the event happens, you got to go down the list, call this function, call this function, call this function, call this function, whenever the event happens. How do you keep that list and how do you do those calls in C#? Well, luckily in .NET, there is what's called a delegate. And a delegate is exactly that. A delegate is a list of methods that you can call or invoke when an event happens. Okay? Now, in the real world, if you look at the dictionary definition of a delegate, it is a person sent or authorized to represent others. It is a representative, someone who is authorized to represent somebody else. Now, in the software world, if you look at the definition of a delegate, it's generally something like it's a pointer to a function or a list of pointers to functions. So you scratch your head and say, wait a minute, how is a list of pointers to functions a representative authorized to represent somebody? Well, this is one of the many times that software terminology leaves you scratching your head. But if we go back to our general concept on what these events, what this event process is, you've got the guy who's completing an event, a task, and he sends out an event. And you've got a bunch of subscribers who are listening to that event notification and doing something. This delegate is kind of the interface between the guy who is sending out the notification and all the subscribers. He is basically acting as a representative to this guy who is going to then contact each of the subscribers with the notification of that event. So he's kind of an interface or a representative for this guy. This guy just hands off the event and leaves it to this delegate to contact the subscribers with the information about that event and to initiate those functions. So you can start to see, yeah, it's basically a list of methods that get invoked, but it's also like an interface or a representative that does the communication for this worker class or method. It's kind of like a presidential press secretary almost. It's somebody who is authorized to represent the president and talk to the media, all the subscribers, and tell them about different events. Okay, so you can kind of sort of see that it's the delegate is what this thing does. It's kind of an interface or a representative. Okay, so let's go a little deeper and see how we would implement this in C#. Here we've got the guy who's doing the work and issuing the event notification, and here we've got each subscriber. So each one, in order to do this, you have to make sure that your worker class or method and your subscriber class or method have implemented certain things before this process will work. Now, the first thing that the worker, the guy who's issuing the event notification and doing the work, first needs to define this event handler delegate, okay? Basically, the list of subscriber methods that are going to be called, he has to define it, all right? He keeps the list of all the subscriber methods that are going to be called, and he also has to define how those functions, those event handler functions in the subscribers will input and output information, what inputs they will take and what they will return. So in our case, we show that each subscriber is going to take just an event indication that this task is complete, and they're going to return nothing. So this kind of defines how the subscriber functions will have input parameters and what they will return. So this guy, his responsibility is to generate that event handler delegate list of methods and also define how this event handler function in each subscriber is going to be laid out. And of course, the next thing he has to do is he has to have a method which actually initiates the event and sends it out. So he's got two things he's got to have inside his class in order for this to work. Now on the subscriber side, of course, he's got to have a method or function that handles the event. All right, we've already said that. He's going to have a function that takes an event and returns nothing. And then inside that function or method, he's got whatever code he needs to do. But the second thing he needs to do is he needs to subscribe. He needs to add his name to this list of event handler functions that are going to be called when the event occurs. So he has to say, hey, I'm out here, add my name to this list, so that when the event occurs, you're going to send me out an event and initiate my event handler function. Okay, so again, this guy has some requirements. He's got to define the event and set up the event handler delegate. He has to define how these functions or methods will look, and he has to actually have a method that initiates the event. And then this guy has got to have an event handler to handle the events and do his whatever functions he wants, and he also has to subscribe. Now, when you do a subscribe, just so you know, .NET makes it kind of a little bit easier. When you subscribe to a event handler delegate, it can automatically use a code snippet to generate an event handler in the correct format. So it's a little bit easier to do that, just so you know, and we'll talk about that a little bit later. So here's a little bit more on how you would do this in C#. Now, so the event handler delegate we showed is kind of a separate thing. In fact, it is defined and resides inside this worker class method. The publisher, the event handler delegate, is defined inside of this worker class or method. So the publisher says he will call the subscriber's event handler methods, each of these methods, but they must be in the correct format or signature. And we already said they take an event, they return nothing. So it's got to be set up to do that. So you can also view this interaction between the publisher and the subscriber as a type of contract that says you've got to set up your event handler method in the right way, and you also have to subscribe, and I have to define the event handler delegate and keep that list in order for this to work. All right? So you can view that as a contract that has to be set up correctly between the publisher and subscriber for this to all work. Now, we talked about the subscriber event handler method or function, and it has to look a certain way. And here is a very typical example of what that method will look like. And you can see it's a method. It's a public void, and here's the name of the method, and it takes two input parameters, and in here you've got whatever code you need to generate. So we said it's going to be public because it has to be accessed remotely by the guy who's adding this to his list of event handler delegates. Okay? So it's public, it's void. We said it's not going to return anything, but it's going to take two types of information. One is the event. We said it's going to take an event. It might also take information about who sent the event. Remember I said he will say, okay, Joe, this is Joe. I completed the task. And I might also tell you, if you want to pick up the copies, you got to go to the table near the water cooler. Well, you can feed this event handler with not only the who sent the event, but also the event itself and more information like where the copies are located. So you can feed this event handler with some information, with typically who sent the event, and also the event itself, which is this event args, and some other information associated with it. So that kind of gives you a general idea of hopefully how all this event stuff works. In the next video, we're going to apply that to a very simple application. And this is going to be an image manipulation application using events. And the way this, just to show you what's coming in the next video a little bit, this application, it's going to be a Windows Forms, and you click on this open image, and it will open an open file dialog, allow you select an image, and it will take in that image and populate these two picture boxes with that image. Then what you do is you click Manipulate Image, and it will modify this image, and it will modify the colors of all the pixels in that image, and it will then, when it's done, it will put that modified image in this second picture box. So you can see the original and the modified. When it's done doing this modification of the colors, that's going to take about 3 seconds. There's about 2 million pixels in this image, so it's going to take a few seconds. And when it's done, it's going to issue an event to the main program that says, hey, I'm finished, and the event handler in the main program is going to get notification of that, and it's going to print in this label. It's going to say the event handler received the notification. So we'll go through that in the next video to show you how to implement events in an application such as this. Take care, and I hope you join me for the second video. Thanks.